Hi there. This is section 8.1. We're moving on to confidence intervals. So the nice thing about confidence intervals are that they are a statistic that you will probably see again. So you are likely to run into confidence intervals in your journals and things that you do in your life. So let's understand them. Here is a problem. This is question 27 on page 382. You guys were moving along through the book. The question reads, you have a random sample of size n equals 16 with a sample mean x bar equals 35 is drawn from a normal population in which sigma, that's the standard deviation, is 2. So you took some sample from a normal population where you knew the standard deviation, you get the mean is 35. So the first question says calculate sigma over the square root of n. Okie dokie. So for part A, we're supposed to calculate sigma over the square root of n. Well, sigma, we said, was 2, and n is 16. We have sigma equals 2, n equals 16, and what was x bar? 35. See right there, 35. 35. So this is going to be 2 over the square root of 16. That's 2 over 4, which is 1/2, or 0.5. That's how you answer part A. Part B of this question, find Z critical for a confidence interval for mu with 95% confidence. So they're basically saying find the critical value, the Z critical value for 95% confidence. You'll notice the critical values don't change too much, and the answer is 1.96. How do I know it's 1.96? Where did that number come from? You're going to use this table. It's right here. You will be given this table on the test. This is from page 373 in your book, but you basically look at this table and you say for a 95% confidence interval, the Z critical value is 1.96, right there. You're probably just going to memorize these numbers, I'm sorry to say, but if you want, you can look it up on this table, 1.96. All right? So we have part A, we have part B. These questions aren't so bad. Let's look at C. Construct and interpret a 95% confidence interval for mu, which is the population mean. So for part C, this is where you need to use a formula. You have x bar, this is the confidence interval formula. X bar plus or minus Z critical times sigma over the square root of n. This is the formula you're going to want to have written down on your card or memorized. So now we plug in. X bar is 35 plus or minus Z critical is 1.96, and sigma over the square root of n, we just found that out, was 5 or 0.5 times 0.5. So all of this, we're going to draw a little line here. Part C. This is 35 plus or minus this 1.96 times 0.5, that's going to be equal to 0.98. So then you get 35 minus 0.98 is 34.03. That's the lower value. And then the upper value is 35 plus 1.98, and that's just 35.98. So it's a pretty straightforward example. We don't know what the population mean is, but here is the confidence interval. I'll draw a red arrow. There it is, right there. That's the confidence interval. We're almost done. One more little piece. Construct and interpret. So now we have to interpret it. So, happily for you, there is one sentence you can always use to interpret a confidence interval, and it is here. We are 95% confident that the true mean, mu, I'll say mu, because I don't want to get into the equation editor, lies between, and now you just plug in the numbers, 34.03 and 35.98. Now, if we'd used 90% confidence, that number would have changed, and we would have replaced the sentence with 90. But this is your interpretation sentence. You will use a sentence like this. Just copy that and you will always be fine. Feel free to kind of make it your own, but just make sure you make it your own in a way that is still statistically accurate. Always a challenge. So that is how you do question number 27. And that should set you up for just constructing a confidence interval and use this sentence to interpret it.